Hi everyone, this is Mrs. Eggerding and you're watching Unit 3 Video 10 and we're going to talk about a technique called completing the square. We will be using this technique a couple times this year, so it's worthwhile to get it right the first time around. We've been talking about graphs of quadratic functions, and we have some of them that are in vertex form and some of them that are in standard form. And if we were to state the vertex, which one you would prefer? Over here in vertex form, it's really easy to see the vertex is at 5, -4. Whereas if we went to the one on the right to state the vertex, you first have to find your x-coordinate, which is 5, and then take that x-coordinate and plug it in to the equation to find your, plus 21. Find your y-coordinate, you get 25 minus 50 plus 21, and g, that's going to end up to be -4. So what we have here are two forms of the exact same equation. One of them is in standard form, the other one's in vertex form. And if all we want to do is find the vertex, this vertex form is pretty convenient. So question is, how do you move from standard form to vertex form? How do we get that? How do we get those to look like that? And so we're going to go back to do some geometry first. And it's called completing the square for a reason. Now here we have a diagram of x squared plus 4x's plus 1. And if you look down here, this isn't something we can factor. It's missing some things. Also, if you notice, going across, I have x plus 2, and going down, I have the x plus 2. And so what happens down here is if I want to complete this square, I need to add 3. Okay? And now what I've done is I've created a square that I can start factoring. Now in algebra, though, you just can't randomly add 3 squares anywhere we want. So what would this look like on my paper? Well, I start off with x squared plus 4x, and I'm going to let this plus 1 hang out for a little while. To make the stuff inside a perfect square, to make the stuff inside be a perfect square, I need 1, 2, 3, 4 ones. So plus 4. Again, in algebra, you can't just add 4s anytime you want. So to keep it balanced, I am going to subtract that same 4 I just added. So here we've made a perfect square. The x plus 2 squared, which is exactly the picture that we have drawn, combining like terms, minus 3. And so that is the completed square version. My vertex would be at -2, -3. So let me show you what it looks like without a diagram here. If we wanted to complete the square for this, I'm first going to start by separating my x's from the 12. And what we need to put in here is we need to put in a number that will make this a perfect square. Now again, depending on how good you are at this, you may know what number to put in, you may not. A good formula to use is what number will be in there will be half of the b term squared. So in this case, it would be half of the 6 squared. Half of 6 is 3, 3 squared is 9. So I add 9 inside the parentheses. Outside the parentheses, I need to do the opposite to keep everything balanced. And so I'm going to put a minus 9 on the outside. The parentheses then factor x plus 3 squared. Combine your like terms. 12 minus 9 is a positive 3. And here we have the function in vertex form with a vertex at negative 3, 3. Well, what if something gets a little bit more complicated? Here I have something that's 2x squared plus 12x plus 5, and I need to create a perfect square out of this. Well, if you start looking across the dimensions going this way it's 2x plus 1, 2, 3, 4. Going down this way, I have x plus 1, 2, 3, 4. It doesn't matter how many little squares I fill in at the bottom. This is never going to be a perfect square. I have 2 x's across the top and only 1 on the bottom. So now what do I do with this? Well, I can break it up into 2 pieces, where I have 1x squared in this group, I have another x squared in this group. The 12x I've split up into 1, 2, 3, 4, 5, 6 x's in one group, 2, 3, 4, 5, 6 x's in the other group. So what I'm doing is I'm taking my 2x squared plus 12x and I am breaking it into 2 groups of x squared plus 6x. The plus 5 I've just randomly put somewhere for what we need now. Now what I can do is take a look at the x squared plus 6 just like I did on the other ones. I want to add 9 inside the parentheses, but wait, 1, 2, 3, 4, 5, 6, 7, 8, 9 in one, but I have 2 sets of 9. And so I didn't really add 9, I really added 18. To balance that out, I need to subtract 18. So to complete the square, I have 2 groups of x plus 3 squared, and 5 minus 18, subtract 13, because those are the number of squares that would have been missing. So again, there's the geometry of what it looks like. I needed to separate one group of the 2x squared and make it into 2 groups that I could make into squares. What does that look like without the geometry? Well, I'm going to take my 3x squared minus 18x, and I'm going to make it into 3 groups of x squared minus 6x. Plus 5 is just going to hang around. Complete the square just like I normally would. Half of the b term squared is half of 6 squared, so again it's plus 9. On the outside, you need to do the opposite. But be careful, completing the square, I added 9 to one set. I had 3 sets I was dealing with. I didn't really add 9, I really added 27. To balance it out, I subtract the 27. And so completing the square, I have 3 sets of x, minus 3, x minus 3 squared, and then 5 minus 27 is negative 22. I can still pull out the vertex to be at 3, negative 22. I know completing the square looks a little bit intimidating, but I think you guys can tackle it. The file's also on the Schoology page on the worksheet. Let me go ahead and do one more example here for you. Let's take something like x squared plus 4x minus 10. Grouping everything together, in the middle, I'm going to take half of the 4 squared. Half of 4 is 2. 2 squared is 4. So I add 4 inside the parentheses, keep it balanced outside, minus 4. Do the opposite. The parentheses factor, x plus 2 squared minus 14. There's the completing the square without a lead coefficient. If there is a lead coefficient, like 2, so let's do 2x squared minus 18. Let's not do 18. It's 2x squared minus 16x plus 11. As I group the x's together, I'm going to make 2 groups. 11 hangs out. To complete the square, half of 8 squared. Half of 8 is 4. Squared is 16. So I add 16 on the inside. On the outside, I need to do the opposite. But it's not just a plus 16. I have 2 sets. So I subtract 32. X squared minus 8x plus 16 is x minus 4 squared. 11 minus 32 is negative 21. We'll work more on this in class. Bring your questions and come visit us if you need to ask any more questions.